Motion is a fundamental concept in physics that describes the change in position of an object over time. This presentation will cover the principles of motion, its types, the forces acting on moving objects, and various applications in real world scenarios. In this presentation, we will explore the fundamentals of motion, including the definitions and types. We will discuss the various types of motion, the forces that influence motion, and how motion operates in different contexts. Finally, we will look at the applications of the motion principles and the future developments in motion studies. Understanding the foundations of motion is essential for studying physics. This section will introduce the basic definitions and concepts that underpin the study of motion. Motion is defined as the change of position of an object with respect to time. There are various types of motion, including linear, rotational, and oscillatory motion, each with unique characteristics. Linear motion occurs when an object moves along a straight path. Example, a car moving on a straight road. Rotational motion involves an object spinning around an axis. Example, a wheel. Oscillatory motion refers to movement that swings back and forth around a central point. Example, a pendulum. The basic concepts of motion are displacement, velocity, and acceleration. Displacement is the change in position of an object from its original location to a new location. Velocity is the rate of change of displacement. That is the rate at which an object's position changes over time, indicating both speed and direction. Acceleration is the rate of change of velocity of an object, indicating how quickly it speeds up or slows down. Understanding these concepts is crucial for analyzing motion. Newton's three laws of motion provide a framework for understanding the relationships between the forces acting on an object and the motion of that object. These laws are foundational to classical mechanics. Newton's first law states that an object at rest stays at rest and an object in motion stays in motion unless acted upon by a net force. The second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Newton's third law states that for every action, there is an equal and opposite reaction, which applies to all interactions between objects. Motion can be categorized into several types, each with distinct characteristics. The types of motion are linear motion, rotational motion, and oscillatory motion. Linear motion is the simplest form of motion. Linear motion occurs along a straight line. The object can move at a constant speed or a changing speed. Uniform motion occurs when an object moves at a constant speed in a straight line, covering equal distances in equal intervals of time. Non-uniform motion involves changes in speed over time, resulting in varying distances covered in equal time intervals. Rotational motion involves objects that rotate around an axis. Key aspects include angular displacement, angular velocity, and the effects of torque on rotating bodies. Oscillatory motion involves repetitive back and forth movements, such as those seen in pendulums and springs. It is characterized by its frequency and amplitude. Forces play a critical role in influencing the motion of objects. This section will discuss the various types of forces that can affect motion. Gravitational force is the attraction that exists between two masses, influencing their behavior in space. Gravitational force keeps objects grounded on Earth and affects their motion in space. The gravitational force plays a critical role in the trajectories of celestial bodies within planetary systems. Frictional force opposes the motion or attempted motion of an object. It plays a vital role in everyday applications, such as walking or driving, by providing the necessary grip. We would struggle to walk or drive without friction. Centripetal force is the force that acts on an object moving in a circular path directed towards the center. Centrifugal force is perceived as an outward force in a rotating reference frame on a body moving around a center. Motion can vary significantly based on the context in which it occurs. This section will examine motion under different conditions. Motion in a vacuum experiences no air resistance, allowing for unobstructed movement. Motion in a medium such as water or air is affected by drag and other forces. This results in slowing their movement and also affects their trajectory. Projectile motion describes the motion of an object thrown into the air, influenced by gravity and initial velocity. It follows a curved trajectory, forming a parabola shape. Relative motion considers how the motion of one object is observed from another object's frame of reference. It highlights the importance of perspective in understanding motion. The principles of motion have widespread applications across various fields. This section will highlight how these principles are utilized in real-world scenarios. In engineering, principles of motion are applied to design machines and structures. Understanding how forces and motion interact is crucial for creating efficient and safe designs. Transportation systems rely heavily on the principles of motion to ensure safety and efficiency. This includes everything from vehicle design to traffic flow management. In sports, understanding motion is essential for improving performance. Biomechanics studies the motion of athletes to develop techniques that enhance efficiency and reduce injury risk. The study of motion continues to evolve, with advancements in technology paving the way for new discoveries. This section will explore what the future may hold for motion studies. Innovations in technology, such as robotics and automation, are transforming our understanding of motion. These advancements open new avenues for research and application in various fields. The exploration of space requires a deep understanding of motion principles, particularly in relation to gravity and propulsion. Ongoing missions are expanding our knowledge of motion beyond Earth. Innovations in transportation, including electric and autonomous vehicles, are redefining how we understand and apply motion principles. These advancements promise greater efficiency and sustainability. Understanding motion is crucial for a wide range of disciplines, from physics to engineering and sports. The principles of motion not only explain how objects move, but also have practical applications that impact our daily lives and future technologies.